Chapter 8.1, Points, Lines, Segments, and Rays. So today we begin our chapter on geometry, and we're really going to split the vocab today kind of into two sections. So first we have points, lines, segments, and rays. So a point is just that. It's a point in space. Okay? Oh. Just a dot. We label that with a letter, typically a capital, and we call that point A. A line connects 2 points, and a line keeps going on forever in both directions. We would label this line as line AB with a symbol above it, a line with 2 small arrows, one on each end. So this indicates that this is a line, and it's a line connecting points A and B, and it goes on forever in both directions. Now a segment is a piece of a line. So here I have the piece of the line between point C and point D. I show a segment by just using a straight line above my 2 points. This one does not have any arrows, indicating that it starts at point C and stops at point D. It does not keep going on forever. A ray starts at one point, goes through the second point, and continues in that one direction. So we use the symbol, a line with one arrow pointing to the right, as our symbol. Now, I have 2 different rays here. Here, A is called my end point. And A is my end point. It's basically, even though it's called an end point, where my ray starts. And AB indicates that I start at A, continue through B, and then keep going. This right here is going the other direction. So I'm going to write that as BA. B is where I start. A is where the point I continue through, and then I keep on going. The symbol above it, however, is still the same. The arrow does not change direction. The letters reverse. Okay? All right, we're going to come back to these 3 for plane, intersecting, parallel, and skew before we do example 2. So let's get into example 1. Name a line, a segment, and a ray. So here we are given a line. So here's my line I'm working with. So this is line XW or line WX. They can be written in either direction, doesn't matter, because it's a line. It continues in both directions. So you can call it a line XW or line WX, either one. The segments work the same way. Just remember the segment symbol is a little bit different. The segment symbol is just the line, so I can have segment WX or XW. Just don't forget the symbol above it. The symbol is very important. That symbol tells me whether it's a line, a segment, or a ray. Now the rays are order dependent. So I have ray WX. That means I am starting here and going this direction. However, ray XW says I'm starting here and going this direction. Notice that the symbol is the same for both. It goes that way. The only thing that changes are that the letters reverse. Okay, so those are points, lines, segments, and rays. Now let's move on to example 2 and talk about how lines and segments can intersect. So we have a plane. So a plane is a flat surface with no thickness that extends in all directions on the surface. So in your book on page 363, which you should have open, there is a drawing of a rectangular prism. I'm going to recommend that you get something rectangular. A Kleenex box works well. Anything that is cube-like or rectangular prism-like. Okay, so if I were to redraw this box, so here's a square. Picture this as the front of that box, okay? It's one surface. This is one plane, and this plane extends in all directions okay? This plane extends in all directions. That is the flat surface. Now, parallel lines, okay? Lines that never touch. Think of railroad tracks, okay? There are two lines that never touch. So on that box, if I was to draw the rest of the box, there we go. So these two lines here are parallel. These two are parallel. But if I draw that box, these two lines are parallel. This line and this line are parallel. This line and this line are parallel. This and this are parallel. These two are parallel. Okay? They're two lines that never cross. Even though here I have three different planes. I have one plane here. I have another plane here. I have a third plane here. These lines are parallel and will never cross. Intersecting lines are lines that do cross at a point. So if I was to label this A, B, C, and I have line AB, okay, it's this one here, and then I take BC, those two intersect at point B. Now the last one that's can be a little confusing are called skew lines. And here's where that Kleenex box is going to come in handy. Skew lines are lines that are not parallel, but they don't intersect. They don't intersect because they lie in different planes. So if you think about line BC that we had here, so here's line BC. And if I take another line, that's an E, F, G. So let's take line DF. These lie in different planes, okay? BC and DF, even though they look like they're going to intersect down here, because they lie in different planes, they are actually never going to intersect. So use that Kleenex box and kind of play with it, okay? And see how the two lines, even though on paper they look like they'll intersect, never actually will. So let's go to example 2. Are the lines indicated on the map below parallel or intersecting? So I have lines A, B, and C, D. So here's A, B. And here's line C, D. So those two are intersecting. Okay, they intersect right here at point C. Now, AB, no, not what I wanted. Line AB and line TW, those are parallel. Okay, those two lines will never intersect. They are parallel. All right, that's it for your examples. Please complete your QCs and your CYUs. If you have any questions, come see me.